So in this video, we'll be using our knowledge of solving quadratics in order to model a real-world situation using a quadratic function, and then use our knowledge of solving quadratics in order to actually solve that particular equation. So let's walk through this example together. Here we see that a monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each $1 increase in price, the magazine loses 2,000 subscribers. How much should the magazine charge to maximize its annual revenue, and what is the annual revenue at this time? So before we even start to write an equation for this situation, let's talk about how revenue is calculated. And revenue is calculated by taking the price of a subscription and multiplying it by the number of subscribers. So what we know here is we first know that one situation that exists is that we charge $20 for our magazine and we end up with 48,000 subscribers. And what we also know is that for every $1 we add, we are going to lose 2,000 subscribers. So I'm going to create some variables to help me create my equation. So here I'm going to have R, which represents the annual revenue. And then I'm going to have X, which represents the number of dollars I add to my price. So this is beyond the original 20 starting mark. So my revenue is calculated by taking my price, which my price is $20 plus some X value. So this is the price of my particular magazine. And it's $20, or it's $20 plus some value that I've decided to add on to it. So remember, X is the number of dollars that we've added on beyond 20. And it's 20 plus X times my number of subscribers, which is going to be 48,000 minus 2,000X. Because remember, we're going to lose 2,000 subscribers for every $1 that we add beyond $20. So that's our equation here. Our revenue equals the price times the number of subscribers, which in this case, the price is 20 plus some X value that we're going to add on to it. And our number of subscribers is 48,000 minus 2,000 subscribers per dollar that we add on. So now that I have my equation here, let's use this equation to our advantage to help us analyze this situation so we can find the maximum revenue. So I know that I'm going to have a parabola that either opens up or down. And looking at this situation, what I notice is that because I'm looking for a maximum revenue charge, odds are that I have a parabola that is opening downwards because it needs to have some sort of maximum point. So I can figure that this is going to be opening downwards and it's going to have that maximum top point. Now from here, I don't know what's going on, but what I do know is that at some point this parabola most likely is crossing the x-axis. And when I'm crossing the x-axis, that's where y is equal to 0. And what's nice about those x-intercept points is I know that the vertex point that I need to find my maximum revenue occurs right in the middle of those two x-intercept points. So if I can find those two x-intercept points, I can then average them and find this middle vertex point between them. So what I'm going to do is I'm going to solve for the x-intercepts here. Remember, when we solve for the x-intercepts, our y value is set equal to 0, which in this case is equal to r. So what we can do here is we can take our entire equation of 20 plus x times 48,000 minus 2,000x, and we can set that equal to 0, and that will help us to identify these x-intercept points. Now what I notice here is the form that this is written in is perfect for the zero product property. It's already factored. So what I can do is I can set each little part equal to 0, so I have 20 plus x is equal to 0. So that becomes minus 20 minus 20. So I have x is equal to a negative 20. And then from here, I can also set 48,000 minus 2,000x equal to 0. I'm going to subtract 48,000 from each side. So I have negative 2,000, x is equal to negative 48,000. Divide by negative 2,000, and I find that x is equal to 24. So what I notice here is that my graph here really isn't that accurate. And so I'm going to draw a new graph here, the new coordinate plane, and I'm going to kind of estimate where my x-intercepts lie. Here I can see I have an x-intercept at negative 20 and an x-intercept at 24. So if I draw this coordinate plane, I can estimate that I have, so I'm going to do 5, 10, 15, 20, and then 5, 10, 15, 20, 25, so that's going to be about right there at 24. So I've got something that looks like that. That's my quadratic there. And what I need to find is I need to find what this vertex point is in the middle. So in order to find our vertex point, what we're going to do is we're going to average our two x-intercepts because we want to find the number that is exactly in between. To find an average, we add the two numbers together, so negative 20 plus 24, and we divide those two numbers by 2. So negative 20 plus 24 is 4. 4 divided by 2 is equal to 2. So I know that my vertex point up here has an x-coordinate of 2. And that 2 represents the number of dollars that we added onto our price. So what that's telling us here is the best price, the price that yields the maximum revenue, is going to be $20 plus 2, which is going to be a price of $22. That's when our maximum revenue is going to occur. Now, in order to figure out what that maximum revenue is, we have to take our x value of 2, and we have to substitute it into our equation here. So we have our revenue equation. So 20 plus 2 becomes 22. 48,000 minus 2,000 times 2 becomes 48,000 minus, that's 4,000. So that becomes 44,000. And if we multiply those two numbers together, we find that our maximum profit when we have a price of $22 is going to be a revenue of $968,000. And we have one final word problem here that focuses on area. So this says, Shuggies currently has an outdoor patio that is 40 feet by 30 feet. They are planning to expand the existing patio by 800 square feet of space to the patio. They plan to extend the patio an equal amount in each direction. How much will they add in each direction to each side of the patio? So let's start here by drawing a picture of what we know. So we know that there is currently a patio there, and it is currently 40 feet by 30 feet. So that's what we currently have for the patio. And what this problem is saying is that we're going to extend the patio out an equal amount in each direction, and we don't know what that amount is, so I'm going to call that x. So we're going to extend this patio out x on each side, and then x on this side as well. So essentially what's going to happen is our new patio is going to be all the way out here. So you can see that we're adding a little bit of area on each side, and we're essentially bumping that patio out x feet in each direction. And our goal is to find x. X equals how many feet in each direction. So that's what our goal is to find by the end of this problem. Now, we're also given an additional piece of information, and we're told that this extra area here is going to add about 800 square feet to the area of our patio. So it's going to add 800 total square feet. So we can see that we're dealing with area because we're going to be updating the area of this patio. So let's start by creating our area equation, because area of a rectangle is simply length times width. And let's fill in what we know about the area total, and then let's fill in what we know about the length and the width. So first, I know that my total area is going to be represented by whatever 40 times 30 is, plus the additional 800 that I'm going to add on. So 40 times 30 is 1,200. So 1,200 plus 800 means that my total area is going to be 2,000 square feet. Then my length is this distance right here. Well, from looking here, I can see that this distance is 40 plus an x in this direction and an x in this direction. So my length is going to be equal to 40 plus those 2x on each side. Then from here, I need to find the width, and the width is this length right here, which I can see is 30 plus an x on each side. So that's going to be times 30 plus 2x. So that's where we start. We take a look at and we see, okay, what do we know about area? What do we know about the length? And what do we know about the width? Now, in order to even start solving this, we need to multiply all of this out and get everything on the same side of the equation. So we need to multiply out 40 times 30 and 40 times 2x, which is 1,200 plus 80x. Then we need to take 2x times 30, which is 60x, and 2x times 2x, which is 4x squared. And then we need to subtract 2,000 from each side, so we get the 0 on the left. And then I'm going to rearrange this as I write it. So I'm going to have 0 equals 4x squared plus 140x, and then that becomes minus 800. So this is the equation that I am currently dealing with. Now, I don't know about you, but if I'm going to use one of my factoring strategies on this, what I'm noticing is that that equation has some pretty large numbers in it. But what I'm also noticing here is that all of these numbers are divisible by 4. So what we can do is we can divide every single value in here by 4 to make this equation a little bit easier to work with. So we have 0 is equal to, that becomes 1x squared plus that becomes 35x, and then that becomes negative 200. So I need to solve that quadratic, which it's not perfect, but at least it's a little bit easier to work with. So I'm going to write this over here. I have 0 equals x squared plus 35x minus 200. So now I need to think through what strategy is going to help me. And what I notice is that I can't use the square root strategy and I can't use the greatest common factor strategy. So I'm going to have to factor this trinomial by using that ABC method. So we notice that a is 1, so we know that we can use a shortcut if we can figure out the values. So we have a is equal to 1, b is equal to 35, and c is equal to negative 200. And then from there I need two numbers that multiply to a times c, which is negative 200, and add to 35. Which might seem like a daunting task here, but it's really not so bad. So if we start to think this through, I'm going to think about the factors of negative 200. And things that I know that multiply to be 200 are 1 and 200, 2 and 100, and those two don't look like they're going to help me add to 35. I also know that I can't divide by 3. Not going to divide nicely by 3, but I know that I have 4 and 50. Those won't add together to be 35. But I also have 5 and 40, and it looks like if I take a combination of positive 40 and negative 5, that those will multiply to be negative 200 and add together to be 35. So what I can do over here is I can take my equation and I can rewrite this as x plus 40 and x minus 5. So I was able to factor that trinomial. And then from here I can use zero product property because I have something times something is equal to 0. And if I set each part equal to 0, so x plus 40 equals 0 and x minus 5 equals 0, I find that x can either be a negative 40 or x can be a positive 5. So now I need to take these values and really apply them to the context of this problem here. This problem is ultimately asking me, what is the amount that they add in each direction to the patio? Well, it wouldn't really make sense to add negative 40 feet to each side of that patio. So instead we know that our answer is 5. And so we're going to add 5 feet to each side of that patio if we want to add in 800 total square feet.